Okay, so section 5.4 is included in the course as sort of a summary of all the methods for factoring. If you look at sections 5.1, 5.2, and 5.3, a lot of information is presented. This one here is just to bring it all into perspective, I suppose. So what we're looking at here is an objective of factoring any polynomial. So here's the idea when you're factoring a polynomial. First, you factor out any common factor. That's what we talked about, finding out if you have a greatest common factor, you factor that out first. That's step one. Now you look, and if it happens to be a binomial, and remember a binomial is a polynomial that has two terms. So the first thing you do is to check and see if it is a difference of squares, a difference of cubes, or a sum of cubes. Remember, there's certain formulas for those, and that's special factoring. So refer to section 5.3 on that. And it happens to be a trinomial. Check to see if it's a perfect square trinomial. If not, use the methods for factoring in section 5.2. And I think there's three objectives that I put forth in videos there for that. Now, this issue of perfect square trinomial, we'll get into that, and there's a certain formula that we follow for that. But there's a video in the chapter 5-6 modules under chapter 5 videos to watch. It's called Problem 19, and it addresses the perfect square trinomial problem that you'll come across in the homework. And if the polynomial has more than three terms, try to factor by grouping. And section 5.1 discusses factoring by grouping. And then once you factor it, just check and see if you can factor it any further. We came to examples specifically in the special factoring section 5.3 where when we did difference of squares, we ended up with another difference of squares and we factored it further. So, and then if you can always check your factoring by multiplying, because remember, factoring undoes multiplication, so you can just redo it by multiplying. So here we go, factor any polynomial. So looking at A, the first thing we notice is we can take out a common factor in A, right? Here we taken out a 10, and we just factored that binomial there by taking out a greatest common factor. Now, looking at B, notice we can take out a greatest common factor here of 2x, because we can take out a 2x out of each one of these terms. And when we do that, we create this factored form of polynomial, and we factored that. Then we might look to see if this factors further. So we have a leading coefficient of 1, so our strategies would be to look at factors of the C term, the last of the terms in there, and see if we can get a product of C, which is -2, and that will sum up to 5. Now, the only factors of 2 are 1 and 2, and there's no combination of 1 and 2 using positives and negatives that will sum up to 5. So this trinomial here is factored to its full extent. So let's move on to C here. And this just emphasizes the factoring by grouping, the magical step that I've often talked about. What we're going to do is take out of both of these terms, we're going to take out the p minus q out of both of these terms. And so we end up with this right here. And that's kind of the magical step of factoring by grouping. And we should be getting familiar with factoring by grouping by now. So when we have a binomial, as we said in the very first slide here, you check to see if you have any of the following patterns. Difference of squares. That's where you have a difference, which is subtraction, right, between two squared numbers or variables. And then we would factor it in this way, right? Remember, the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And then we had difference of cubes, where we have the difference of subtraction between two cubes, right? So we have the cube root of the first minus the cube root of the second times the square of the first cube root plus the product of the two cube roots plus the second cube root squared. Then we have sum of cubes, remember? We have a addition between two cubes. So we have the cube root of the first plus the cube root of the second times the square of the first cube root minus the product of the two cube roots plus the last cube root squared. That's when we end up with a binomial. So anytime you have a binomial, check to make sure that it fits, if it fits one of these categories. So here we have in A, notice 36 is a perfect square, right? Then we have x squared and we have y squared. So that is the difference of squares. So we rewrite it in this way using the reverse power rule here, because 6 squared is 36, x squared here. Then we write this here. So we have our first and second terms in the binomial written this way. And remember, we're using the difference of two squares formula here. So here we have it. We put the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So that's the difference of two squares. And in B, we have a sum of squares. But remember, there is no formula, special factoring formula for sum of squares. So the binomial is prime. And remember, prime means that it can't be factored any further. So looking at C, looking at 125, we can see that the cube root of 125 is 5, and then we got x cubed here. Then we got negative 27y cubed. So let's rewrite this here, because the cube root of 125 is 5, the cube root of 27 is 3. We rewrote it using the reverse power rule here. And remember, so we have a difference of cubes. So remember, the difference of cubes formula is this right here. So what we do is we put in the cube root of the first minus the cube root of the second times the cube root of the first squared plus the product of the two cube roots. Well, I'm talking about and plus the last cube root squared. Remember, we have to clean this up in order to make it the proper format, especially when you try to enter these things into my math lab. It wants them in the proper format. So what we would do, we would just clean this up a little bit here. The 5x minus 3y remains the same. We use the power rule here. We square 5. We square the x. We go ahead and multiply out this on out to get 15xy. Then we square the 3 and we square the y squared, the y to get y squared. And then this happens to be missing a parenthesis. There should be a parenthesis here for this to be in the proper format. And then here's the issue of the factoring of a perfect square trinomial. Now you can use these formulas to factor, but if you're not comfortable and you're like, hey, that's just another formula I got to remember, you can go ahead and use the strategies that we had in 5.2 to go ahead and factor it. So don't feel like you have to memorize another formula and apply it. you can do it in normal ways. But and as I said, there is a video in the chapter 5-6 module resources called problem number 19 that does address a perfect square trinomial. So if looking at A, this happens to be a perfect square trinomial because 16, the square root of 16 is 4, and the square root of 49 is 7. And if we were to do 4 times 7, we would get 28. And if we were to double 28, we would end up with 56. So this is a perfect square trinomial. And as I said, refer to problem number 19 video to do this. But notice that we can factor this here as 4m plus 7, 4m plus 7, which is the same thing as 4m plus 7 squared. And it says this is a perfect square trinomial. So looking at B here, now there's something particular about B. Is one, we notice that the leading coefficient here is not 1. And so we're going to have to use, and I think what we end up using here is the AC method. So we multiply the first times the last. 8 times 5 is 40. And we're going to look for factors of 40 that sum up to the middle term of negative 13. So what we did was calculate AC. Refer to section 5.2 if you've forgotten the AC method. There's a lot of detailed examples in the 5.2 video that demonstrate the AC method a little bit more thoroughly than we're going over right here. But we're looking at factors of 40 that sum up to the middle term. Notice if we were to make negative 5 times 8, we would get a positive 40. If we were to sum up negative 5 and negative 8, we would get negative 13. So remember, using the AC method, we rewrite the middle term here. We rewrite the middle term using the factors of AC that we determined. As I said, normally, if you look at the 5.2 videos, I show you how to list all those factors and do an analysis to find those two factors. But notice what we've done here is rewrite the middle term, negative 13t, as negative 5t minus 8t. Remember, the next thing we do is to group the 4 terms into 2 groups, which is what we've done here, 8t squared minus 5t, plus, and remember they're separated by a plus sign, negative 8t plus 5. And remember, the next thing we do is take out the greatest common factor out of each group. So looking at the first group, it looks like the greatest common factor is going to be t, and it looks like in the second group it's going to be negative 1. So what we've done here is we've created a common factor of 8t minus 5. And we took out a negative 1, a very important step there. And then remember, the next step is to factor out of this entire polynomial here is to factor out the 8t minus 5, and we end up with the factored form of the polynomial. So here we have another one, and this one looks a little more complicated here. But first thing we notice is that we can factor out a 3 out of each one of these terms. That'll make it a lot easier to factor out a 3 out of each one of these terms. Now we have another trinomial here, 2x squared minus x minus 21, which is going to be a lot easier to factor. But remember, the first thing we do is factor out the common factor here of 3. So what we're looking at here, we're going to calculate AC by multiplying the first times the last. So 2 times negative 21 gets us negative 42. And so we're looking at factors of AC that sum up to the middle term. So then we would, as I said, and looking at some of the examples in 5.2, we would list all those factors, and then we would determine which one of those sum up to -1. And it just so happens that -7 and 6 get us -42, but they also, when they're added, they add up to the middle term here. So remember, we're using the AC method, so we rewrite the middle term using the factors that we found when we were analyzing AC. So remember, notice 7x plus 6x adds up to -x. We rewrite the middle term. Then we would group this, right? And they kind of skipped a step here, but we would group these two things. And then we would take out the greatest common factor. So out of 2x squared minus 7x, the greatest common factor is x. And then out of this 6x minus 21, the greatest common factor is 3. So we took a 3 out of that. We created this common factor of 2x minus 7. So we take out the 2x minus 7, and we've just factored that trinomial there using the AC method.